In question 3 of this series, we are asked to find the number of atoms in a copper rod with a length of 9.85 centimeters and a radius of 1.05 centimeters. The density of copper is 8.96 grams per centimeters cubed. The key to answering this question is to understand the shape of a rod. A rod takes on a cylindrical form. So let's pretend that we have a cylinder that looks like this, and it has a length of 9.85 centimeters, and its radius, which is the distance from here to the center of the circle, is 1.05 centimeters. What we have to do is find out the number of atoms. To do this, we need to first use the volume formula for a cylinder, which looks like this. Volume is equal to pi r squared h, where h represents 9.85 and r represents 1.05. Substitute these values into here, find out our volume. Using our volume, we can use the density to find the number of grams. Then, once we found the number of grams, we can find out how many moles there are, and then from there find out the number of atoms. So this is the opposite of what we did in questions 1 and 2. Let's go ahead and find the volume first. Volume is equal to pi, that's a given number. Our radius is 1.05 to the power of 2 times our height of 9.85. Pi times bracket 1.05 to the power of 2 times 9.85. This gives me 34.1165. And we will be taking into account significant figures. We are working with 3 significant figures here, so our final answer should also have 3 significant figures. Although I don't want to start rounding right now because there are a lot more calculations left. I'll put a dot underneath the last significant number. And the units for volume here are centimeters cubed. Now that I found my volume, I can use this relationship to find out the number of grams. I'll take my volume, 34.1165, and multiply it by 8.96 grams per every 1 centimeter cubed. I've also gone ahead and placed the units here. They're important because we want to keep track of the units canceling out. The centimeters cubed here and the centimeters cubed here will cancel out, giving us the mass. Let's go ahead and multiply these numbers. We'll take this number and multiply it by 8.96. Notice that I took the whole number for this multiplication because whether you have 3 numbers after the last significant number or more, it's not going to affect the final answer. So multiplying these two, I end up with 305. And I'll write down my answer up until this 4, even though I know my final answer should have 3 significant figures. So 305.684 grams. That is how many grams are in this rod. Now that I found the mass, I can take this number and multiply it by this relationship. Here's how. So I have my number written down. I'll multiply it by 1 mole per every 63.546 grams. The grams will cancel out, leaving me with the number of moles once again. I'm going to do that calculation. I'm going to put a dot underneath this 5 just so that I can keep track. 305.684 divided by 63.546. This gives me 4.81. 4.81, and let's write a few more numbers. 0.43. 0.43 moles. I have the number of moles. My last step is to use this relationship to find the number of atoms. Here's how. I'll multiply this number by Avogadro's number, which is 6.022 times 10 to the power of 23. 6.022 times 10 to the power of 23 atoms per every 1 mole. The mole unit will cancel out. And finally, we can get our answer, 4.81043 times 6.022. My final answer should have 3 significant figures, don't forget. to the power of 23. I get 2.89. Everything after this 9 is insignificant, although this 6 is greater than 5. So this 9 will round up. We get 2.90 times 10 to the power of 24 atoms. And there you have it. Our last example based on the mole concept.